Good day, dear participants of the conference. To your attention is presented study on the topic Study of the energy parameters of the system, solar panels, solar inverter, electric network. The generation and consumption of electricity in the world is constantly growing. At the same time, the generation of electricity from alternative energy source, including solar photovoltaic panels, is also growing rapidly. In 2022, total electrical power generation of all solar panels was about 716 gigawatt-hour. That is approximately 3% of the world's total electricity. The conversion of sunlight into electric current with the help of the photoelectric effect occurs in solar photovoltaic cells. To implement the function of maximum power selection from the solar panel in the DC-DC converter, it is necessary to ensure the implementation of the input current value adjustment for maximum power selection from the solar panel. The purpose of the study is to obtain scientific result of the process transferring electrical energy from solar panels through a hybrid solar inverter to a three-phase electrical network. One of the most important characteristics of solar panels is its current voltage characteristic, the shape of which depends on the level of solar radiation and temperature. For an example, consider the volt-ampere characteristic of the solar panel type ERA 317W24V, figure 1. At the same time, the current voltage characteristics of the solar panel largely depend on the temperature of the panel, while an increase in temperature reduces the generated power, figure 2. The dependence of the power of solar panel on consumed current is shown in figure 3. It can be seen that the solar panels has a point of generation of maximum power, which is determined by amount of current consumed by the solar panel. Determining the maximum power generation point can be done by exact calculation by polynomial approximation of the solar panel current voltage characteristics and using solar radiation and temperature sensors. Thus, by regulation the solar panel current, it is possible to obtain the maximum power that is functionality realized by the semiconductor converter that takes power from the solar panel. Converters, called solar inverters or hybrid inverters, perform the functions of selection electrical energy from solar panels, operating in the maximum power generation mode and ensuring the transmission of electrical energy to the general industrial electrical network. Figure 4. To implement the function of maximum power selection from the solar panel in the DC-DC converter, it is necessary to ensure the implementation of the input current value adjustment. To determine the parameters of the intensity of the power of electrical energy which is generated in the solar panel, as well as the implementation of the selection maximum tension in the solar panels. A computer simulation model has been developed which is shown in figure 5. The main parameters of the MATLAB model of the power active filter are given in table 1. In the model, the block of solar panels consists of 500 solar panels type Soltec 1STH 215P. It's 15 series modules, 10 parallel strings. The maximum current generated by the block of solar panels is 17.5 ampere. The maximum power generated by the block of solar panels is 1415 volt. The maximum power of a block 500 solar panels is 106.57 kilowatt. At a solar radiation level of 1000 watt per square meter and at a temperature of 25. Current voltage characteristic of set 500 solar panels simulated in MATLAB model is shown in figure 6. The control system of the hybrid inverter is implemented on the basis of control system of the power active filter with pulse width modulation, control with the adjustment modulation frequency from 1 to 10 kHz. The structure of the control system implemented in the model is shown in figure 7. The implementation of the maximum power selection in the hybrid inverter is implemented by controlling the phase current of the solar inverter by setting the modulation coefficient. Transient processes of current, voltage and power of solar panels at the start of solar inverter are shown in figure 8. As can be seen, the voltage of the block of solar panels increases from zero during startup. As is known, the condition for the implementation of the power factor correction mode and the formation of the sinusoidal form of the generated current is that the voltage in the direct current link of the solar inverters is higher than the amplitude value of the line voltage of the network, into which the energy from the solar panels will be transferred. Therefore, to improve the startup mode of the solar inverter, it is advisable to perform the startup with a precharge capacitor of the inverter to the level of a large amplitude value of the line voltage of network, figure 9. The power factor in the mode of generating electricity to the electric grids is 0.991. The results of the harmonic analysis of the form the current generated from the solar inverter to the electric grid are shown in figure 10. As can be seen from figure 10, the current generated from the solar inverter to the electrical network has a harmonic distortion coefficient equal to 3.63%, and the amplitude value of all harmonics in the spectrum does not exceed 2.4%, which meets the requirements of international standards. The results of polynomial approximation of the energy characteristics of power transistors at a temperature of 25 are given in the following expressions. To calculate the efficiency of the hybrid inverter, the characteristics of the IGBT module type CM1200 DC 44 years with a nominal current of 1200 ampere and a nominal voltage of 1700 volt were taken. The characteristics for which the calculation was given and which determine power losses are shown in Figure 11. The calculation carried out during modeling determined the dependence of the amount of power loss in one power switch of the inverter as a function of the pulse width modulation frequency in Figure 12. Dependence of power losses in the power transistor on the pulse width modulation frequency at a DC link voltage of 1500 volt and a current amplitude of 223 ampere, maximum power point of solar panels. Thus, the efficiency of the hybrid inverter when transferring electricity from the solar panels to the electrical network was from 98.4% at a pulse width modulation frequency of 1 kHz to 92.7% at a pulse width modulation frequency of 6 kHz. The last slide presents the conclusions of the study. Thank you for attention.